Yes, sir.
The mass of a body is a measure of the amount of substance in the body. It reduces the change in the state of motion or rest of the body. Okay, that's called inertia, right?
Yes, sir. Inertia. Yeah.
The gravitational field strength. Explain what is meant by gravitational field. The reason why gravitational force works. Okay. So you got here 250 Newton. Here you got
Yes, sir.
100 Newton meter. You got here 100 Newton meter. Then you got here 250 multiplied by 0.40, right?
Yes, sir.
So should you take 0.40? Or 0.1?
Sir, the radius of the sun. Sir, 0 point because it's the handle length. That's why.
Yeah, what is the rule? You are taking
Per
perpendicular distance from the pivot,
distance
right?
from the pivot. Yes, sir. Yeah.
So the handle where you are applying force from there, your pivot is here, right? Pivot is here.
Yes, sir. Yes, sir.
So we have here 1.2 right here, 0.12.
Yes, sir.
So
Yes, sir.
you should take this distance. Huh? This is a tricky part.
Oh,
Okay, perpendicular
yes, sir.
distance.
Oh, 1, 2.
So
Yes.
correct it, correct it. Then check what is your answer coming.
Yes. 1.2. 300 Newton meter.
300 or 30?
Wait.
0.12.
Oh, yes, sir. Sorry. The
Yeah,
30 Newton meter.
30. So
Yes, sir.
if it is 30,
Yes.
then you are getting 1 mark here. You are losing 1 mark because for the formula here we have 1 mark.
Yes.
So you are losing 1 mark.
Oh,
Okay.
yes, sir. So the second part is also wrong then.
What will be the answer of second part then?
It will be 0.4 f into 0.4 f equals to 30. So it will become um, 75
So write it.
Newton.
Write it 75 Newton.
Yes, sir.
So you have
Yes,
here
sir.
actually moment, right? So friction, this one is coming and it's also affecting the force, right?
Yes, sir.
And if you are writing thermal energy, it's going to energy, right?
So will yeah.
If it
So
is going,
like forces needed for the energy, I guess.
yeah, forces needed to get the energy, but we
Yeah.
are actually here dealing with the force and distance from the pivot, right? So
Yes, sir.
here you can bring some other sources of forces, like you brought one force, that is friction. You can bring also the idea of weight of rope, okay,
Oh.
because that one also increasing the force. uh, is it clear?
Sir, like the force is greater because of the weight of the rope.
Mhm. Mhm. Because weight of the rope
Yes.
we are not considering here, right? uh,
Oh, yes, yes.
so that
Oh, so
could
it's
also
like
cause,
we'll need more. Yes,
yeah.
yeah. Weight of the rope. Yeah.
Hmm.
So, but thermal energy, will it be like wrong?
No, it's not wrong. Your idea is correct, but
Yes.
it's not appropriate here to write. That means it's not bringing mark to write it here. Is it clear?
Oh,
You
oh,
bring
yes,
the
sir.
idea of
Yeah.
forces here, sources of forces, how the moment is affected. Is it clear?
Oh, yeah, yes, sir. Now I get it. Like, it is not appropriate because, like, it's about the forces and, like,
Yeah, your idea
even,
is correct. Idea is not
yes,
wrong, but it's
yes.
not they asked you for. Okay.
Oh, oh, yes. Now I get it. Yes, sir. Yes, yes. So here I will give -1.
Yeah, here you give -1, then there you also give -1, huh? Where you got wrong.
Yes, sir. Yeah.
Yeah, that one. 30 Newton meter, there you will get -1, then 75
Yes.
Newton, there you will get -1, and
The
here -1. So three
yes.
marks lost here.
Yes, sir.
Yeah. Now, next one. State the energy changes that are taking place as the bucket is being lifted at a constant speed. The thermal energy of what you wrote? What you wrote, can you?
The chemical
Okay,
energy of the farmer changes into kinetic energy. The kinetic energy later changes to thermal energy.
okay, okay,
So they gave like 3 marks, so I wrote like three different energy names.
okay, okay, great. So you wrote chemical energy, then gravitational potential energy, then thermal energy, right?
Yes, sir. So kinetic energy, I wrote. Will it
Okay,
be
you
wrong?
wrote kinetic energy.
Yes, sir.
So chemical energy is came to kinetic energy. Actually, he's lifting it, right?
Yes, sir.
He's
Yeah.
lifting it. So the
Mhm.
the most precise one should be gravitational potential energy, right? And
Oh,
yeah, because
yes.
he's lifting it up, right?
Yeah. Yes,
He's
sir.
he's having
Mm.
kinetic energy, but that's not
Yes.
the more precise. Precise one is
Oh,
gravitational potential energy, right?
sure, sure. Yes,
Then,
sir.
then instead of kinetic energy, you replace it with
Mhm.
gravitational potential energy. Okay.
Yes, sir.
and thermal energy,
Then
right?
I, yes, so thermal energy.
So here I don't, though broad kinetic energy, I don't give here -1 because that is also happening.
Yes,
More appropriate is
yes,
gravitational potential energy. Is it clear
yes,
to you?
sir. Yes, sir. The
Okay, so
gravitational potential energy will be like more appropriate because he's lifting
yeah,
it, so like the height increases,
yes,
which is
yes,
why the gravitation.
yeah.
Yes, I
So
get it.
here you don't give -1 is fine with this one.
Okay, sir.
Okay, then the next what you wrote,
The upward force is equal to the downward force.
upward force is equal to downward force. So there is no resultant force, right?
Yes, sir.
Upward force, uh, upward force, downward force is weight, right?
Yes, sir.
Okay. And upward force is tension force, right?
Yes, sir.
Both are equal. Okay,
Yeah.
very good. Then here both are correct,
Uh,
right?
yes, sir.
Okay. So
So,
here one
so
mark.
after that, oh, so there is no mind canceling, like no negative marks over here.
No, 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 no negative marks here.
And then,
Then
sir, I gave the acceleration arrow towards the earth.
no problem. Then here
Oh, yes, sir. So towards the earth, I gave.
it is correct. Yeah, read. That is coming
Yes, sir.
later, right? Showing
Yeah.
the direction it's coming later. So read what you wrote.
Speed only has magnitude, but velocity has both magnitude and direction.
Okay, continue next.
As the direction changes with the with the time, the velocity also changes. Therefore, the satellite accelerates.
As the again read.
As the direction changes with time, the velocity also changes. Therefore, the satellite accelerates.
Okay, so here velocity changes the direction, right?
Yes. Yes.
That's why we are
The
getting the
di-
acceleration.
yes, sir.
Okay, so the we have actually linear motion and circular motion, right? So
Yes, sir.
in linear motion we have change in magnitude of velocity to get acceleration, right?
Yes, sir. Yeah.
But in circular motion we don't have change in magnitude of velocity. Rather we have change in direction of velocity, right?
Yes,
Isn't it?
sir. The direction changes.
We
Yes,
have
sir.
constant speed. We get here acceleration due to direction change, right? Is it
Yes,
clear?
sir. Yes, sir. So I wrote the direction changes with time, so the velocity changes, therefore acceleration changes. So
Hmm.
like,
It's okay. It's
will
okay.
I get like 1 marks for
Hmm.
it?
Hmm.
Or like 2 marks?
You
Should I like elaborate it more?
no, it's okay. It's okay. So your answer is correct. Huh?
Okay,
Like
sir.
direction change you mentioned. That's why you are getting 1 mark. Uh, and with time the velocity changes. That for that one you are getting another mark. Okay.
Oh, yes, sir.
Clear.
I get it. Yes.
Can you read this part?
Yes, sir. The force does not work as the object does not move in direction of the force. The energy also stays the same as it does not lose any energy.
Yes, correct.
Yes.
Correct. This one is correct. The next, can
So
you read it?
next I wrote mass is the measure of amount of substance in a body.
Then next,
Electronic balance I gave.
yeah, very good. Then next,
And then it is 6.1 joules. I wrote the formula, then I calculated it
yeah,
by
correct.
substituting the mass and velocity. So there here I will not lose any marks.
No,
Okay. Sir. Then sir I gave retardation.
yes,
So, so if I wrote deceleration, it would also be correct, right?
yes, yes. Deceleration is
Then
also
sir,
correct.
okay, sir. Then sir I wrote it does under the x-axis goes to negative. It goes under the x-axis to the negative side of the velocity.
Again, read please.
Yes, sir. It goes under the x-axis, goes to the negative side of the velocity. Like the curve goes under the x-axis, which is like the negative velocity.
Negative acceleration. Okay.
Yes, sir. So will it be like wrong or like correct?
No, it's fine.
Okay.
Yeah, negative gradient or line
Yes.
slopes downwards.
Mm. Yes, sir.
Negative acceleration means deceleration, right? When you are
Yes,
having
sir.
the with time increases, your velocity decreases, right?
Yes, sir. Yes, sir.
Actually, they are asking you not what you meant that one. They are asking you even this one, like here,
Yes, sir.
upper part
Yes,
also
sir.
we are getting deceleration, right?
Yes, sir. Yes.
So this part is
Hmm.
deceleration. Why? Because we are having
Yeah. Negative gradient.
negative gradient. That's why.
Oh.
So this one should be appropriate answer.
Minus.
Yeah, minus one.
Yes.
Yeah.
Uh, then, sir, I gave 0.08 seconds.
So here you write correctly. This one
Yes, sir.
correctly
Uh,
write.
yes, sir.
Negative slope or negative gradient.
Yes, I wrote it, sir.
Yeah. Then here you give minus one. That will be better.
Yeah.
Then
Yes, sir.
your the time at which the ball stops moving upwards, is it 0.08 seconds? Okay, look, listen. If
Yes, sir. Yes, sir.
it is moving upwards, and
Yes, sir.
when it is moving upwards, at one stage it will stop,
Yes.
right, and then return back.
Yes, sir.
And
Yes,
when it
sir.
is stopped, that time the velocity is zero, right?
Yes, sir.
So look in the graph.
Oh,
Look in the
yes.
graph. where the velocity is zero, the time. What is the time over there? You see, here v equals zero here, right?
Yes, sir.
So what is the time here?
So the time will be
Check
zero
out.
point 0.9 seconds.
Yeah, you check from the graph,
Yes, sir.
get it, get it to the point accurately.
Okay, sir.
Then tell me the value.
1.2. It is no, no, wait. I did a mistake. So 0.84. So it is coming 0.84.
0.84 or
84.
0.88?
Uh, 0. Point,
Yeah, scaling you
yes, sir.
get correctly.
1, 2, 1 divided by 2. 0.1. Yes, sir. 0.88 it will be.
Yeah, so got it? How to measure it?
Yes, sir. Yes, sir.
And in this measuring, you learned
Yes,
something,
sir.
right? You
Yes,
learned
sir.
how to get the scaling, right? How to get the values
Yes,
from
sir.
there. And when you got 0.84,
Yes,
uh,
sir.
at that time you took the scaling wrongly, right?
Yes, sir. That time I took
You
the
got
scale
it
wrong.
correctly.
Yes.
So now your answer is correct,
Yeah.
huh? It's correct now.
Yeah. Okay, sir.
Now it's correct. Then here you give -1, huh?
Yes, sir. So what about the distance?
Okay, let us check the distance then.
Yes, sir. It will be then half into uh, so distance. So there's a negative part. So how should I take the distance?
Yeah, negative part is there, but no problem with the negative part. You just get the. They are asking you about the distance for the distance traveled before the ball stops moving upwards. And so they are asking you about only this part, the upper part.
Oh yes, sir. Oh, there'll be half into 0.88 into uh 8.5, right, sir?
It was 8.5 the height. Are you
Yes,
sure?
sir.
Are you sure?
Mm, so
You
let
see,
me
again
check.
you are doing the same wrong like before.
Okay, yes, sir. 1, 2, 3, 4.
I see it's 8.8.
Oh, yes, sir. 8.8 it will be because 2 divided by 5, 0.4. So like 0.4 plus 0.4 plus 8, 8.8. Yes, sir.
Then check what is the answer coming.
Okay. So 3.872.
3.872, then you can write 3.87.
Yes, sir.
Three,
3.87.
yeah, three significant figures is fine.
Figures.
So here you are getting minus
Yes,
one.
sir.
Okay, minus one.
Yes,
The
sir.
formula is giving you 1 mark. The
Yes.
formula for this you are getting credit one, but for the answer line you are losing mark. Okay.
Yes, sir.
So here you got uh, in two part two you got minus
Yes,
one,
sir.
right?
Yes, sir.
Then the time of which the ball stops moving upwards, for then you are getting minus one.
Yes, sir.
Then previously you gave minus one. That is done, right?
Yes.
Now
Yes, sir.
suggest why the graph in figure 8.2 almost vertical when time 1.84
Yes, sir.
seconds. The ball has reached the ground.
Reach the ground. Yes, sir. Like it was thrown vertically upwards, then it fall down on the ground.
Yeah, in 1.84 seconds, right?
Yes, sir. So that time the graph is almost vertical.
Yeah, yeah. This is because
Because
ball hits the
yeah.
ground, right?
Yes.
That's correct. Then figure 8.2 shows that the ball remains
Yes, sir.
stationary after a time of
Hmm.
1.84 seconds. Describe the energy change that is occurring at a time of 1.84 seconds. Kinetic energy is converted to gravitational or thermal energy.
Uh, so it just stopped moving. So like the kinetic energy will be converted.
Then it is converting because it's there is friction with the ground, right?
Oh
And
yes.
there is thermal energy, right? And,
Oh
and if it is returning
yes.
back, then you will see that
Yeah.
is not
Yes,
uh,
sir.
is not lifted up that much like before, because already some energy is
Oh
lost as thermal energy with the heating in the ground.
yes, sir. Oh yes, sir. Now I get it.
Hmm.
So I will get -1 here.
Hmm. Then it's C.
Then in C I wrote
What you wrote?
the graph will be more steeper.
Now, can
Less
you read
time
the
will be
question?
taken.
Can you read the question, please?
Oh yes, sir. See, for this ball moving in a way shown, the effect of air resistance is negligible. When a ball with a much smaller mass is hit vertically upwards at the same speed, air resistance produces a noticeable effect on its motion. Suggest two ways in which the velocity time graph for ball with a smaller mass differs from figure 8.2. So the graph will be more steeper and less time will be taken to complete the revolution.
So the graph will be more steeper.
So the mass will decrease, so uh, the acceleration should increase. They're inversely proportional, that's why.
Hmm.
Yes, sir.
Uh, Here,
Yes, sir.
uh, can you read the? I am opening the question. Actually, it's not clear here. That's why
Oh, okay, sir.
I'm opening the question. Huh?
Yes, sir.
I can see it clearly.
Um, yes, sir. This one.
Effect of air resistance is negligible, right?
Yes, sir.
Actually, they are now uh,
Yes, sir.
giving us something with air resistance. That is drag
Yes, sir.
force. Drag force working on the
Oh,
smaller ball, right? So
yes,
uh,
sir.
we have to focus over there. So
Yes,
if it
sir.
is smaller ball, then air resistance will work on it less.
Yeah, yes, sir. Yeah,
Hmm.
the resistance will work less.
So
But
if
before we also didn't consider air resistors.
sorry,
Like before graph they also didn't consider air resistance.
yes, but
So
now
yeah,
they are mentioning clearly air
yes,
resistance
sir.
produces a noticeable effect on its
Yes, sir.
motion. So this part is giving us something, special, observation, right?
Yes, sir.
So
Yes,
can
sir.
you
Yeah.
underline this part? So,
Yes, sir.
so bigger ball will face, uh,
Mhm.
bigger ball will face more air resistance, and a smaller ball will face less air
Yes.
resistance. So, what is happening that time? If its air resistance is
Mhm.
working less, then
Yes, sir.
its speed, the upward speed,
Mhm.
yeah, you are
Yes.
throwing with the same force, but as the air resistance is
Yes.
working less, the
Yes. Yes, sir.
upward speed will be more, right?
Yes, sir.
Because the deceleration is now less, isn't it?
Yes, sir. Yeah.
So if it is more, speed, that means the line will be more steeper. This
Yes,
is
sir. I wrote this. The
this
graph
is
will be
the
more
yeah,
steeper.
the graph will be more steeper. This is one thing. Then
Yes, sir.
area under the graph will be also smaller, right?
But sir, if they cover the same distance,
Yeah,
so the
they
velocity under will be the same.
uh, listen. They if your
Yes,
speed
sir.
is more, then
Yes, sir.
what will happen? It can go more upwards, right? That means
Yes, sir.
it will go more up, right?
Yes, sir. It will.
Isn't it? It will go more up.
Yeah.
So
Yeah.
that is one point, and the
Yes, sir.
time to reach the
Hmm.
maximum
Yes.
height will take less, right?
Yes, I
Isn't it?
wrote this one. Yeah.
So this one should come here. So these
Yes,
points
sir.
will be there in our graph, right? They are asking about the
Yes, sir.
graph, from figure to art
Yeah.
will be different.
Hmm.
Let us see your writing.
Yes,
Uh,
sir.
the graph will be more steeper, you wrote. This is
Yes, sir.
correct. That time will be given. What you said? Time
So less time will be taken to complete the revolution.
revolution. Will it be revolution better or
Like the journey
yeah, like the
of the ball.
journey, or you can
Yes.
say to reach the maximum height. This way you can say revolution
Yes, sir.
is
Okay.
something like circular motion type, and the idea
Yeah.
is coming
Yes,
from
sir.
that.
Oh.
Is it clear?
Yes, sir.
Okay,
Yes,
fine.
sir.
Your answer is correct. Then next,
Then, sir, I wrote uh, time. It unit I gave seconds. Then I wrote current. I gave its unit ampere, and then I wrote temperature, and its unit is Kelvin.
they gave mass and length.
Yes, sir. Mass and length they have given me. So they told to write other SI based quantities and their
So,
units.
so here you wrote nano 10 to the power minus 6.
Uh, yes, sir.
It should be minus 9.
So it was pico, right? -9.
Minus 9 is nano and minus 12
No.
is pico.
Oh. Oh. Okay. Yes. Yes, sir.
And cent is correct, then mega is correct, tera is correct. So here you are losing 1 mark,
Mm.
minus 1.
Yes, sir. Yes, sir.
So what is the
Yes, sir.
unit here given? Mass, what is the unit given here?
The mass they give unit 64 grams.
So don't you need to
Oh.
convert it?
Oh, yes. So it will become 0.064 kg into 10. So
Hmm.
0.64 Newton.
Yeah, so correct it and then give here minus 1.
-1. Yes, sir. Yes, sir. I give given.
Okay, then on figure 10.1,
Yes.
the first answer they said, you see, A. A
Yes,
you
sir.
did not label, or you labeled
Uh,
here.
so C I labeled.
Okay, okay, I
Like,
see. I
oh,
can see here now. But the
yes, sir.
C will be just at the above
Yeah.
of the pivot because
Uh,
we are balancing it here. So
yes, sir.
here is the center of mass.
Yes, sir.
Just above the pivot on the screwdriver, you give C. Okay.
Okay, sir. Above pivot. Yes, sir. So it will be center just above the pivot.
Uh-huh.
Yes, sir.
And here give minus 1. Then here on figure
The
10.1,
weight.
draw an
Yes, sir.
arrow to show the weight. Weight is also here, right?
Yes, sir. Weight will also be here.
Yeah, weight will be also there. So you are losing here 2 marks for the same mistake.
Yeah. Yes, sir.
Okay, then here you go. Last question, right?
Yes, sir. Yes, sir.
Okay, so here you got, yeah, atmospheric pressure also works here. And now
Yes,
calculate
sir.
the force exerted on the base of the tank. Here you should take this one, 4.2.
Uh, yeah, yeah. Oh,
Check with that one, then check what is
yes,
your answer coming. And here you give -1. For the formula, you're getting 1 mark.
yes, sir. 1.89 into 10 to the power, uh, 10 to the power 7.
Yes, 1 point.
1.89 into 10 to the power 7.
Correct, correct. So you write here -1,
Yes, sir.
and
Yes, sir.
count how
Yeah.
many marks you lost. All the minus you count, and then tell me what is your total marks you are getting. You subtract the minus marks from 75. Okay.
Okay, sir. So 58 I am getting.
58. So right here,
Yes, sir.
58 by 75 equals, you find it
Yes,
in
sir.
percentage.
Uh, yes, sir. 58. So where would I write it? Like
Yeah,
in the
total,
total part?
total. 58 divided 75.
75. Yes, sir. Then the percentage is 77.3%.
Then you write
70.
77%.
Yes, sir. So it's a
77%.
B. Yes, sir.
58 out of. So we are
Hmm.
writing also here in our Google Classroom.
Yes, sir.
50,
Yeah.
topical,
So 58
yeah, topical
divided.
mock
Yes, sir.
P2 score
Yeah. Yes,
of
sir.
IFAS.
Yes, sir.
IFAS.
Yes,
How
sir.
much it is? 58,
It is 58 out of 75.
75. That
Yes,
is
sir.
77%.
77%. Yes, sir.
Okay. Done. So it is a record in our Google Classroom also, right?
Yes, sir.
And you preserve it also and write there today's date. We checked it today.
Yes, sir.
Write there today's date. So thank you so much for joining class and taking part in the discussion. Your
Yes,
mock
sir.
topical mock to paper will be given on Sunday. Paper 1 Sunday and paper 2 Tuesday. Okay,
Okay, sir. Okay, sir.
and you finish them and send me by Thursday.
Yeah.
Okay.
Oh, sir. On which topic it is thermal, right?
Yeah, I already gave you, right? The
No,
topical
sir. The
topical mock the chapters I already gave you. Plan, mock
the
plan.
routine. Yes, sir. Yes, sir. The routine I got.
So there is not mentioned.
Yes, sir. There is mentioned.
So
Yes.
yeah. So what is the use of this routine? You should check it, right? Energy
Yes,
and
sir.
thermal
Yeah.
physics. There are five
Yeah.
topics. You revise them and then take part. Huh?
Yes, sir. Yes,
On
sir.
Sunday you will get the paper, inshallah. Okay.
Okay, sir.
Allah Hafiz, eh?
Assalamu alaikum, sir.
Salam.